Cool. Yeah. So today we're talking about pointers and memory. We used to call this lecture pass by value versus pass by reference, and I think that's still kind of the crux of it. And really, what this has to do is with essentially in JavaScript, when you're copying or using values, one kind of concept that is easy to forget or to gloss over is this idea that when you look at a variable, when you look at a value, what are you actually looking at? Are you looking at a copy of the value, or are you looking at that specific value, or are you looking at that specific value? So we're going to take a look at a few examples to kind of understand how JavaScript handles that type of behavior. Give me a second, let me move this down. Okay, cool. All right. So just as a quick refresher at the beginning, we talked about primitive data types versus complex data types in JavaScript. The primitives are listed there, and basically everything that's not a primitive is a complex data type. It's somewhat misleading because everything in JavaScript is fundamentally an object. That's why they call it that's why they call JavaScript an object-oriented program. But for our purposes, when we say complex or primitive, just remember the main distinction between the two is that primitive values, once it's created, they can never be changed, whereas complex values can be changed. So if I create a number or I create a string, I can't really ever edit that number or edit that string. What I could do is I could replace that number or that string with a brand new number or brand new string, right? Or rather, I can replace a variable with a brand new number or a brand new string, but I can't edit that string. So I can't just say, hey, in this string, take out the last four letters. What I can do is I can make a brand new string of the original string, except I don't add in the last four except I don't add in the last four letters. On the complex side, it's different, right? Remember our sessions on arrays and objects. I can have an array with three things. I can add one more thing to the end of it, and now I have an array with four things, right? So the ability to edit, the edit or change of value makes it complex, and so therefore everything that we can't change is a primitive data type. Yeah, so if I look at, for example, strings, which are primitive values, if I have one variable called British city and I set it to the string York, and then for another variable I have another variable called American city, and I set it equal to British city, and then I edit American city. In this case, I take the American city value and I add in the string new to it. Well, when I console log out British city and I console log out American city, two things are happening, right? One is, if you notice, British city is not being changed, right? And that makes sense because the string York on line 2 there, that's a primitive value. I set it equal to the variable British city, and I never replace British city with any other value. And so therefore, because it's a primitive value that I never replace, the value of British city can never be changed, right? So that's why on line 7 there, when I console log out British city, it's still York. On the American city side, I set it equal to British city. So after line 3, if I was to console log out American city would also be the string York. But then on line 5, notice how I override whatever previous value of American city with a new value, and that new value is the string new plus the old value of American city, which was York. And so therefore, that's why when I print out American city, I print out New York, because on line 5 there, I was actually able to replace the previous value of American city with a brand new value. One distinction to draw here is that, and something that is a bit subtle, but you'll see why this is really important, is that on line 3 there, when I set American city equal to British city, right? What I'm really doing is is that even though the American city value becomes the string York, it's a different version, or is a different copy, or rather it's a copy of the string York from British city. And we'll see in a little bit why that's really important for us to know, right? But here the most important thing is just to realize that when I do this, British city does not get changed, whereas American city does, and that's because on line 5 there, we override American city, but we never override we never override British city anywhere else in the code. If I was to take a look at something that would be a more of a complex value, we can see why this would be different, right? So here on line 2, I have the British city equal to equal to the array with a string called York. On line 3 there, I set American city equal to British city. And now, as we covered in the lesson for arrays, all unshift does is unshift takes in a value and adds that value to the beginning of the array. And so here on line 5, I basically take the American city array and I add an element called new to the beginning of the array. Now I console log out British city, I console log out American city. Notice how now they both are the same value, and they're both an array with two values now, new and then York. Okay, and so this once again harps at kind of like the main difference between arrays and strings. And basically, this is when we talk about passing a value. It basically means, hey, let's take one value and use it somewhere else. Here on line 3, we're taking the value of British city and we're using it in the American city variable. The only difference here is that because this is a complex value, the British city value that is being used on line 2 is the same value as the one that is being used on line 3. And so why do they behave differently? That's the kind of point of today's lesson. So we're going to try to diagram it out for you in a little bit. Okay, so whenever we have a primitive value, so things like numbers, strings, booleans, etc., whenever we create a value of that, or sorry, whenever we create a variable that stores that value, what we're doing is we're actually not storing that value. We're actually storing a copy of the value. So here on line 4, I create a variable called first, and we set it equal to the value 20, right? And if you look in the bottom right-hand corner of your screen, we have a variable called first, and it ties it to the value of 20. If I overwrite that variable with another value, what I've basically done now is I've said, hey, the variable first is still the same, except now it points to another value, in this case 30. Okay, and so that's the reason why even though between line 4 and line 5 we changed the value of first from 20 to 30, we never really changed the value of 20, right? 20 is still always 20. The only difference now is the variable first now is pointing to 30 instead of 20. Okay. If we juxtapose that with another example here on line 7, if I have a variable called second and I set it equal to 30, well, even though the values are the same, the second variable is obviously a different variable than the variable first, but the value that it points to is actually a separate value called 30, right? So even though both variables have the same quote-unquote value of 30, they're different instances or different copies of 30. And so now if I change the variable if I change the variable second, if I do plus plus, which now basically says, hey, take whatever value you had, add 1 to it, and replace it with the old value. Now you can notice how even though I changed the variable second, nothing happened to the variable first, right? So this one I think is fairly intuitive for most folks to understand, because all we're really saying is, hey, here's a variable. Whenever we have an equal sign, it points it to a new value, and even if we have multiple variables pointing to the same primitive value, those values are still separate, as in whatever changes we make to one will not impact the other. The flip side of that then will be what happens if we do something like this. Let first equal to 20, so we still have that, and then we say let second equal to first. What happens now? And so here's where the primitive behaves differently than complex values, right? With a primitive value on line 2 there, when we create a variable second, we're still creating the variable second. We set it equal to the variable first. At that point, what JavaScript do is JavaScript will go to the variable called first. It will say, oh great, what value are you? And then first will say, I'm a primitive value, I'm the number 20. And then JavaScript will say, okay, great, I am going to make the variable second also equal to 20, but once again, it will be a copy of 20. It won't be the same version of 20. And so that's why the arrow is drawn the way it is on the bottom right-hand side, right? So we have two variables now, first and second. They're both pointing to the value of 20, but those are different values of 20. And so therefore, if I on line 4 there, if I try to add 1 to the variable second, I now change the value of whatever the variable second was pointing at to 21. But once again, there's no connection, there's no impact of that on the variable first. Does that make sense so far?
Yep.
Yep. And so this is what we mean when we say something is called pass by value, right? So like when I use the value of first, what I do is I actually copy the value of 20, or I copy the value of that variable and I use it elsewhere. Um, okay. Oh, sorry, keyboard stopped working all of a sudden. Okay. So let's contrast that to what happens when we do a complex value, right? And this brings us to the contrast to pass by value, which is called pass by reference, which means that when I use a value of a complex variable, I'm actually using the reference in the memory, which means I'm actually using that version of the variable. So how that looks with an example is here on line 7, I still have my variable first, and now it points to the array with two values in it, 10, 20. Okay, the array is a complex value, and so therefore, this chart is slightly misleading because primitive data types also have a reference. Think of a reference as just a place in the computer's memory where the value is being stored. Okay, so here I have a variable called first, and I say go to the array. If I change that array now, the reference doesn't change. The information is still located in the same place, but now we just added number 30, right? So now we're fundamentally changing that value. And if we do the same thing to first that we did in the previous example, so here we have the variable first, and we say go to the array 10, 20. If I set another variable equal to the same exact value, I think most people intuitively kind of get this. Like even though like these two values are the same, like they're different, right? Like they're distinct. It's like saying like I bought a Toyota Camry, and my parents also bought a Toyota Camry. Even though the make and model of the car might be the same, they're two different cars, right? So same idea here. If I change, so even with complex variables, if I have two variables pointing to the same value, if I change one of them, it doesn't impact the other. Where things get a little bit kind of crazy or a little bit more different than maybe what we might have seen in the previous examples with primitives is then what happens when we do this. I still have my variable called first. I set it equal to the array 10, 20. But now I create another variable second, and I set it equal to the value of first. Well, with primitives and pass by value, notice how when JavaScript asks first, where were you? First said I'm the number 20, and we made a copy of 20, and we use that going forward. With complex values, JavaScript asks first, like, what are you? And first will say, I'm a complex value, and then JavaScript will say, great, use that copy of that value, like use that value, right? And so that's why if you look at the chart on the bottom right hand side, right, for complex values is the variable second now points to another, the variable second now points to the same reference, which points to the same value as first. And so now if I was to change second, as in if I was to change whatever value second was pointing to and added 30 to the end of the array, well, because second and first, the two variables both point to the same reference and therefore they both point to the same value, the value of first was changed alongside the value of second. And so this is why in the opening example we used, right, when I had the array with the string York and I added new, I made a copy of it, then I added new to it, this is exactly what happened. Because both variables, both American city variable as well as the British city variable were pointing to the same values, whenever I changed the value of 1 through one variable, it automatically changed it for the other two. Because once again, both variables are pointing to the same thing, right? It's like two people living in the same house. If one of them says, I painted my house green, well, the other person's house now also became green because they both live in the same place. Everything good so far?
Yep.
Great.
It is pretty intuitive.
Yep. Yeah. Once you just kind of recognize like this is how JavaScript treats complex versus primitive values, the rest of it kind of flows through very logically, right? And the only reason why JavaScript does this is because complex values are changeable, right? And so whenever you have multiple variables using the same complex value, JavaScript wants to make sure that you are looking at that version because that version could change down the road. With primitives, because they can't be changed, JavaScript pretty much just says, hey, use this value, and I'm pretty confident that this is the value going to be going forward because you can never change it, so it kind of has to be that. So yeah, and so this is why one of the things that when we covered the array section, especially when we cover slice, we said, hey, if you ever want to make a copy of an array, always do that array.slice, because when you do that, what you actually do is you're actually creating a brand new array which has similar values. But once again, notice how on the bottom there, right? even though the two variables have the same values, they're pointing to different references, and so therefore, whatever you do to one of the values will not impact, the other variable value combination. Yep. Cool. So in the real world, kind of how does this happen? We see a lot when we talk about using values, and one of the most common ways that values are used in JavaScript is when we pass them into functions, right? Most functions are you take in some values, you do something to it, and then you give back another value. And so here, if I take a look at passing in values on line 1, I have a variable called mynum. I set equals to the number 10. On line 3 through 6, I have a function called adds20 that takes in that variable called num, and I add 20 to that number, and I return that number. Okay, so here if I actually try to run that function, on line 8, I create a new variable called return num, set it equal to the function adds20, and that takes in my num. So if I console log out my num and return num, what happens is on line 8 there, on the right hand of the equal sign, my num is a number 10, and that gets passed into the function adds20, which takes me now to line 3, right? At this point, the variable num becomes 10. The question now becomes, is num 10, or is a num the variable my num? And the answer is, well, what data type is my num? It's a number, so it's a primitive. And so therefore, when my num is being passed into the adds20 function, we're not passing in that value of 10, we're passing in a copy of 10, right? Because 10 is a primitive. And so therefore, on line 4, all we're saying is let's add 20 to 10, and then therefore in line 5, let's return 30. And so when we return 30, that gets returned to line 8 now, and now on line 8 we say let return num equal 30. And so when I console log out my num on line 10, that my num was never overridden, so because it was defined as 10 on line 1, it will still be 10, but then return num then becomes 30 because that was what was returned coming out of the function. And so this is us passing in a primitive value. If we were to contrast this with us passing back a complex value, then let's just do it with arrays now, right? We have an array with a number 10 in it. On line 3, we have a function called pushes20, which takes in an array and then adds 20 as another element to that array, and then we return the array. So here on line 8, if I was to say, hey, let return array equals, if let return array equals the function pushes20, and we pass in my array, and then we check what everything is. Well, on line 8 there, on the right-hand side of the equal sign, my array is an array with a number 10. We pass that into the pushes20 function. What data type is my array? It's a complex data type. And so what gets passed into the pushes20 function is not a copy of that array. It is that array, right? So therefore, the array parameter on line 3 there becomes the my array variable on line 1. On line 4, when we do array.push20, we're basically pushing 20 onto array, which is also my array. And on line 5, we return array, which is also my array. And we return to line 8, which then gets assigned. And so when we console log out both my array as well as return array, you notice that both now have 20 appended to the end of it, because once again, when my array was passed into the pushes20 function on line 8, we're not pushing a copy of that array. We are pushing in that actual array, right? Like we're not saying here's a copy of my work, here's the actual array. And so whatever changes you make to my array is also going to be reflected in array, and vice versa. And so that's like kind of in the real world, kind of one just thing to be careful about when you're dealing with complex versus primitive values is when you're using these values back and forth, always make sure that in the back of your mind you're keeping track of, am I changing the underlying value? And that's a question that we touched on a little bit when we talked about arrays, but it's actually a very kind of important software programming kind of concept to be careful with in general, is because a lot of times you want to take a value and you want to use it. If you want to just read the value, that's usually very, very safe. If you want to start changing it, then you really need to be careful and ask yourself, do I want to change the underlying value so that everyone else who uses this also sees a change? Kind of like when we talked about global variables a little bit. Or do I want to make a copy of it and then change only that copy? And so that's a pretty important concept that most people kind of need to learn through some kind of trial by fire, unfortunately. Hopefully with this now, it becomes a little bit clearer what the distinction in JavaScript is between the double equal signs and the triple equal signs. For primitive values, double equal signs and triple equal signs work more or less the same way. With complex values, they differ a little bit because the triple equal sign will compare complex values by reference, not by the value. And so what that means is if I have this example here on line 3 and line 4, I have two variables, array 1 and array 2. They're both equal to the same exact value in terms of the array value. But if I try to use a triple equal sign, I get back false. And the reason why is when JavaScript traces back array 1 and traces back array 2, they're not comparing by the value, they're comparing by their reference. So if you remember the earlier slide when we had like kind of like the arrows pointing from one variable to the reference, all it checks is to see if those two variables are pointing to the same reference, not the same value. And so whereas this is not an equality under the triple equal sign, something like this would be, right? I have array 1, I set it equal to the array 1, 2, 3. I take array 2 and I set it equal to array 1. Now I have two variables, array 2 and array 1. They're both pointing to the same reference, and so therefore they by definition have to point to the same value. And so if I was to do array 1 triple equals array 2, I would get back true.
Okay. So in order to compare, let's say you do have array 1, array 2, and they're pointing, and they have different references. The only way you could triple compare them is by looping each one and comparing the values inside.
Yeah. So that actually wouldn't be triple compare. That would be because triple compare by definition means you're comparing the references. But if you're asking like how do I check to make sure these two arrays have the same values, that would be how you would do it, and that's actually one of your workshop problems too. So you'll get a chance to try that out. Yeah, and so this is why when we talk about triple equals, we tell people like, hey, be careful when you use triple equals when you compare arrays and objects, because what a human thinks is equal is not what a computer thinks.
If array 1 is double equal to array 2, it's just telling you that they're both arrays?
Sorry, so...
Or if you're if you try with double equal, what information do you have when you double equal arrays? Would the two arrays with different values double equal each other?
Yep. So you're saying if I have something like this now, right? And then I have array 2 equals the same thing. If I console.log out ARR1 equals ARR2, I'm gonna get back false.
No, but double equals.
And your question is what happens if we do this?
Okay, so double equal is false also.
Yeah, because once again, right, like what double equals, like double equals, if you remember our lesson on coercion, we talk about coercion. The idea behind a double equals is, so triple equal says you have to be the same type and the same value. With double equals, what it does is it tries its best to coerce something to the same type, and then it compares the values. But that coercion is actually very complicated in terms of the double equal matrix. Do JavaScript equal matrix. I think it's something like this. Yeah. So if you use double equals, if you're trying to compare like an array versus another array, for example, I actually don't know how to read this because this is kind of bad, but okay. I guess you cannot compare two arrays just like that. You can. So basically, if I would try to compare one object to another object using double equals, okay. I guess by definition, the objects compare through triple equals. If I was to compare an object to a Boolean using double equals, what it will do is it will convert the Boolean to a number, and it will convert the object to a primitive. So this is like the matrix for how JavaScript thinks about using double equal comparisons. It's actually very complicated, and in general, you will very rarely see people use this in the real world, just because whoever uses it needs to be kind of very careful with this matrix of how JavaScript does comparisons. In general, people always use triple equal for everything. And if you're trying to compare a number to a string, for example, and you want to compare them in a way that tries to make the value, you would explicitly change either the number or the string first to the other data type, and then compare them using triple equals. So the short of it is like this is a kind of another reason why you should always be using triple equals instead of double equals. Okay. But relative to kind of the topic here at hand, it's just that the way that JavaScript sees, object equality is not the way that humans sees it. because JavaScript sees object equality is based on the reference, not by the value. And then the last thing we'll also say is that the way that JavaScript arrays does slice is a bit tricky too. Earlier we talked about how using .slice was a way to make a copy of an array, but all that actually does is it makes what we call a shallow copy. And so what that means is here on line 3, if I have an array 1 that has 2 values in it, the number 1 as well as an inner nested array with a value 2, 3. If I do array1.slice, what that does is it copies array 1, and so on the surface, if I console log out array 2 on line 6, it looks the same. And when I console log out array 1, is it the same reference as array 2? The answer is no, it's not, right? Because I sliced it, I made a copy of it. But notice how if I do the same exact thing, but now all I do is in that second element there, that inner nested array in array 1, if I push number 4 and I console log out that array 2, that value as well, you'll see that even though the arrays themselves are not triple equal, the second element in array 1 is equal to the second is triple equal to the second element in array 2. And the reason why is because when we use .slice, all it does is it goes to the array one time and takes whatever value that is and copies that. If that value is a primitive, then it copies it by the value. If that value is a complex value, then all it does is it copies that reference. And so if I wanted to make for example, if I wanted to make 2 arrays that were distinct from each other entirely, that would require me to make something called a deep copy, which requires me to go through every single value and keep copying every single value until it reaches a primitive state. Okay, so even though array.slice will work for the vast majority of cases when you're copying an array, if that array also contains inner nested objects, then .slice will not always work. So that's just something to be careful of going forward. And so that's pretty much it, right? We talked about primitive versus complex data types. We talked about how variable assignments work for both complex and variable types, and then we saw how it works when we try to use those values into functions. And then we discussed the way that triple equals compares objects, and the fact that array.slice only makes shallow copies, which means it will copy all the primitive values inside the array, but if your array has any nested complex values, it will only copy the references for those, and so you're not creating 2 distinct copies.
So remind me, what is PBV and PBR?
Oh, sorry, PBV is passed by value, so that just means when I take a primitive, I take the value, and then PBR is passed by reference.
Okay, sounds good.
Cool. Any questions on those things?
No.
Cool.
I'll get to work in a bit.
Cool. Awesome. Yeah, just make sure.
Thanks a lot.
Yeah, no problem. Yeah, so